Great, so today we'll finish up law of sines, looking at that last case that's a little tricky. That's the side-side angle case. So out of all the cases that we learned, angle, side angle, angle, side, side angle, this is the only one that you got to be careful about. Two solution, one solution, no solution. Okay? Even when we learn law of cosines tomorrow, you're never going to have to worry about that two solution stuff. This is the only one. Okay, so just again, reminder of what the law of sines is. So you got your sine of alpha over A equals sine beta over B equals sine gamma over C. Now, do you use all three fractions at the same time? No, right? You only use two at a time. Either the first two, the last two, or the first one and the last one. Okay, so as far as me explaining stuff, really, I already explained everything yesterday, so that's it. We're just going to start with an example right away. Okay, so I want to solve this triangle. Now, I'll sketch the first one out, but you can tell what kind of problem it is without sketching it. What do you look for in the table that tells you it's law of sines? Anyone remember? Yep?
A full row.
Full row. Okay, I got a full row, so I know it's law of sines. Now, does anybody remember what else you can look for that tells you it's the worst case for law of sines? It's the one where you got to worry about no solution, two solution, one solution. It's what?
Two sides.
Two sides? Okay. Yes, we have two sides, and that's what the case is. We're also going to have two sides tomorrow. So technically, we haven't learned that one yet. So if you see two sides, then you would automatically know as of today that it's the worst case. But does anybody remember what else you can look for in the table? There's something here that I don't like in this table. Yep?
There's a full empty row.
Yeah, there's an empty row. There's a row with nothing in it. There's no way for me to find anything in it. That tells me that it's the worst case. All right? Now, if you forgot that, you can always sketch it. A cross from alpha. B cross from beta. C cross from gamma. Look at the information you have. You've got a side, and you've got an angle. Okay. What makes this the worst case is the angle is not between the two sides. If the angle was here, this would be a problem we would do tomorrow. That's side, angle, side. But today, it's side, angle. So with side, angle, Aiden, what do I have to find first here?
The beta.
Yep, I got to do this one first. Now, notice in the box where I wrote beta, I put it up a little higher. Just in case there's a second answer, I'll put it lower. If there isn't, then, okay, I got a little extra space there. But if there is, I've got room for it. Okay, so let's set it up to find beta. Kayla, can you tell me what my proportion will be to find beta?
Be sine beta over 35.
Careful, you don't want to mix your rows. This one side of the proportion is one row, the other side is the other row. So this side is going to be all your beta stuff on the left. So sine beta over 8. Yep. And then what about on the right?
Sine 35 over 6.
Yes. Yep. Sine 35 over 6. Now you could have switched it. If you did sine 35 over 6 on the left, that's fine. You put sine beta over 8 on the right, that's okay. You're going to cross multiply, so it doesn't matter. All right, so let's cross multiply. And Devin, can you tell me what I get when I cross multiply?
8 sine 35 and 6 sine beta.
Equals 6 sine beta. Yep. So now we want to get beta by itself. Two things we got to get rid of. Get rid of the thing that's furthest away first. So Aaron, what would I get rid of first here? Well, the 6 and the sine are two separate things.
Oh.
So let's pick one of them.
This.
The 6. And how would you get rid of the 6? Yep, divide each side by
6.
Yeah, divide by 6. Divide by 6. Okay, so that's gone. So now I've got 8 sine 35 over 6 equals sine beta. Now I want to get rid of sine. Okay? Remember, sine is not arithmetic, it's a function. So you've got to use a function that cancels it out. What's the opposite of sine? Inverse. Yep. So we take the inverse sine of what's on the right. Those cancel. Inverse sine of what's on the left. Now, when I type that in, what's one thing that could happen? I get no solution. Yeah. What's another thing that could happen? I get a solution. So one of two things. I get an answer or I don't. Let's type it in and see what happens this time. Second, inverse sine. 8 sine 35 divided by 6. So yeah, we get 49.886. So, assuming I've typed everything in correct up to this point, is this a no solution problem? No, I just got a solution. 49.886. So let's put that right there. Now, can I go on to find gamma, or is there something else I have to do with beta? I have to check if there's another answer. So to do that, I take the answer that I have and do what with it?
You subtract it from 180.
Subtract it from 180. So 180 minus 49.886. So if there is another answer to this problem, that's what it is. It's 130.114. Now, do I just write that number down and say, yep, that's the second answer?
You put it back through?
Well, I have to do something with it. What do I have to check?
If it equals 180.
Well, it equals 130. So I know that number you're saying if the second angle equals 180.
What about the 35?
Okay, what about the 35?
You will subtract it. Because I mean, if it's 180,
All right, so I'm hearing all the right numbers. I'm just not hearing quite the right exact thing to do. How do I determine if that second answer works?
you add them.
Add it to what?
35 and 130.
Yep, okay, so add the 130 and 35 together. And what do you hope happens if the second answer is going to work? It has to add up to exactly 180?
Less than 180.
Less than 180, right? So you have to take the angle that you were given and take the second answer, add them together and see if it comes out less than 180. If it does, then the second answer works. If the second answer and the other answer add up to like 190, that's too big. And the second answer is not going to work. So we were given the 35. If we add it, are we less than 180? Yes. So the second answer does work. Okay. Any questions on how we got that second answer? And then how we determine that it works? Now, beta has two solutions. So what else does that mean?
Gamma's gonna have to.
Yep, gamma's gonna have two. And what else?
C's gonna have 2.
C's gonna have two. Yep, very good. All right. So what we're doing now is we're really solving two problems at the same time. Okay. Let me put like colored dots next to the triangles. I'm going to call them, one problem we're solving is the red triangle. The other problem we're going to solve, I'll call it the green triangle. Okay. Alpha is in the red triangle. Beta 1 is in the red triangle. Gamma 1 is in the red triangle. Those are the three angles that we're working with in the red triangle. In the green triangle, alpha is in the green triangle, beta 2 is in the green triangle, gamma 2 is in the green triangle. So notice alpha is shared. It's in both. Okay? The beta 1 and the gamma 1 are just in the red. The beta 2 and the gamma 2 are just in the green. Right? And you could do the same thing with the sides. A is part of the red triangle, B is part of the red triangle, C1 is part of the red triangle. A is also part of the green, B is part of the green, and C2 is part of the green. So now if you look up there, there should be 6 red dots, 3 angles, 3 sides, and 6 green dots, 3 angles, 3 sides. So that, I'm just trying to make it clear what information belongs to what triangle. Any questions on that?
So there's 2?
There's 2, yep, there's 2. We're doing 2 triangles at the same time. And you don't normally call them red and green, I just call them red and green.
Alright, this is like dumb, but how can beta be 130 if it's like this big? Like if you look at the diagram, the angle is like that.
Oh, my diagram is definitely not to scale. Yeah, none of my diagrams that I draw are ever to scale. You don't have to worry about drawing it to scale.
Okay.
I will draw something and show you how this actually works.
So like, how can it be both though?
I'll show you.
Okay.
I'm actually going to give you an example of the 2 solutions case, and I'm actually going to sketch it. Yep. So I'll do that in a second. All right. So now we're ready to get gamma 1 and gamma 2. How would you get gamma 1? What 2 angles are going to be involved? Yep.
Alpha and beta 1.
Yes. And what would you do with alpha and beta 1?
Add them together, subtract them from 180.
Yep. So take beta 1, take alpha. That adds up to 84.886. Subtract it from 180. So gamma 1 is 95.114. Okay. How about gamma 2? What 2 angles are going to be involved to find that? Yeah. Alpha and beta 2. Add those up. That's 165.114. And subtract that from 180. We get 14.886. Now we don't have any empty rows. Okay. So now we can find C1 and we can find C2. Okay. So let's set it up for C1. So we're going to have sine of something over something, sine of something over something. Now, C1 is part of the red triangle. So, you have 2 red rows that are complete. A, alpha, that's a red row. So is B, beta 1. That's another red row. So, should I use B, beta 1, or should I use A, alpha? Yeah, go with A and alpha because it was given and there's no decimals. So sine 35 over 6. So start with that. And now we're finding C1. So what angle do you think I have to use to find C1? Gamma 1. C1 finds gamma 1, C2, gamma 2. So let's do it. C1, we don't know. Gamma 1, 95.114. Okay, I'll come back and I'll solve that in a second. Let's set up C2. Okay. To find C2, C2 is the green triangle. I have 2 green rows that are complete. B, beta 2, that's a green row. A, alpha, that's a green row. Which row should I use? Oh, Con? Which row do you think we should use?
Sure.
Right? Do you know what we're solving for?
No.
All right, can someone remind me, what are we solving for? C2. Okay, so we're finding C2. Setting it up. So what row should I use to find C2? Yeah, right? You got 2 green rows that are complete. Why did you pick the first one? Yeah, they're easier numbers. They were all given. There's no decimals. So plug in the first row. It's the same row you've used 2 times in a row. Sine 35 over 6. You used it there. Sine 35 over 6. You used it there. And use it again. Sine 35 over 6. It's a very important row. And now we got to find C2. So Jasmine, what angle will help us to find C2?
Gamma 2?
Yes. To find C2, use gamma 2. Use the one that's right across from it. So sine 14.886 over C2. Right. Now let's cross multiply on each one of them. So C1 equals, how about Ben, can you tell me what C1 would come out to? Not as a decimal, just tell me like what times what divided by what.
I have no idea.
All right, what do you have to do to solve this?
I need a calculator, I guess.
No, I just want to know what you have to do. You don't actually have to do it. Just tell me, like, if you had this proportion, how do you solve a proportion?
Multiply.
You cross multiply, right? So you're gonna have, what would you do? How do you cross multiply?
6 times sine 95.
All right, so you got 6 times sine 95.114. Yep.
And then sine 35. Or C1 sine 35, or what would it be?
Yep, C1 sine 35, and what would go between those two things you said? So you gave me a calculator, you said like, you gave me something times something, and then you said something times something.
Equals.
Equals, yeah. You put that equal sign between them. So 6 sine 95 equals C1 sine 35, and then you'd have to divide by sine 35 and get that on the other side. And now C1 is by itself. You just have to plug it in. All right, let's try again. Okay, how about C2? Peter, can you tell me what C2 would be? Again, no, you don't have to do it out. I just want to know. Yeah.
Yeah, 6 sine 14 886 and then equal and sine 35.
And where does the sine 35 go? Yep, sine 35 in the bottom. Okay. So we'll type them in and see what we get. So it's not that a 2-solution problem is harder, it's longer. You're not doing more difficult things, you're doing the same thing twice. Okay? Just got to set it up twice in a row. Yeah.
I'm just wondering why only half of the problem is 2 solutions.
Because the stuff that they give you never has 2 solutions. When we talk about having 2 different triangles, we're not saying that they're totally different. We're saying 3 of the things are different. That's what the 2-solution case means.
So like if you were trying to find A, there would be A1 and A2?
If you were finding A, yes. But since A was given to you, whatever is given to you, that only has 1 solution. Okay.
That's weird.
Yep. So when you're solving a problem that has 2 solutions, it doesn't mean that they're 2 totally different triangles. Triangles have some things in common. They have 3 things in common, and then they have 3 things that are different. That's what 2-solution case means. Okay. And I'm going to sketch that out for you in a second. All right, so let's get C1. So we got 6 sine 95.114 divided by sine 35. Okay. So anyone who tried that on their own, did you get 10.419? Yep. Okay, then you did it right. Or we all did it wrong. Right, so 10.419. And now let's do C2. Okay, all I have to do for C2, if I just bring up the last calculation I just typed in, change 95.114 to 14.886. I don't know if that's faster than retyping the whole thing, but that's how I do it. And I got 2.687. And those are all your sides and all your angles. Yeah.
I'm sorry, but I'm not seeing any difference from the other problem. How do we know when there's two answers?
So can anybody answer how we figured out that there were two answers? So we got this, and then we did something with it. We did something with it to get this number, and then we checked something. So we did two things. Yep.
Didn't you subtract that number by 180?
We subtracted that number from 180. So we had the 49.886. We subtracted it from 180 and we got that number. So that's how we got the second solution. But how did we figure out that it works? Yesterday it did, we crossed it out. Yep.
And then if the second solution at 35 is more than 180.
Yeah. We checked the angle that we were given, which was 35, and what we think the second solution is. And we said, can they fit? Will they both fit in the same triangle? And the answer here is yes. Because if you add 35 to 130, you only get 165. Now, let's say the second answer came out to 170. Now, if the second answer came out to 170, and you try to fit that in a triangle with a 35, would it fit? No. 170 is too big because if you add 35 to it, you get 205. Okay? So if it comes out bigger than 180, you cross out the second solution. If it doesn't, like in this case, you got to write it down.
So you know how we subtracted, like you know how you got 130?
Yep, we did
That
one, yep.
And that was that beta 2?
Yep.
Could you do that for the other ones and just subtract it from 180 and then add 35 and get like the second answer for every single one?
You mean for these two?
Yeah.
But that's what we did. So all we did was we added this one and subtracted from 180. And then we added this one and subtracted from 180. That's how we got the other two. Any other questions on that one? And so what I want to look at now is how can that work? Right? So here's a triangle. And I'm going to sketch another triangle for you that has exactly two sides the same length. Like I'm actually going to measure it out and do it all to scale this time. Two of the sides are going to be the same, and one of the angles is going to be the same. But the triangles that I'm going to draw are going to be totally different. Okay? So let's just take this side and make a copy. Does everyone agree that this side and that side are the same length? Have I done any trickery? Okay. So those two sides are the same length. Now, I'm going to take this side, I'm going to make a copy of it, and I'm going to flip it. Did I change the length of it? No. I just made a mirror image of it. So I'm going to put that side right there. So that side and that side are the same length. Okay, so we got two lengths that are exactly the same. And now I'm going to draw in the third side, like this. I didn't quite put this perfect, but it's close. All right, so there's my third side. Now, if you're looking at it, you're like, wait, where's the angle that's the same? They do share an angle. Does anybody see what angle is the same in each of these triangles?
Bottom left.
Yep. Bottom left angle is exactly the same in each triangle. So, I just drew two different triangles that have two sides exactly the same length and one angle exactly the same size, but they're not the same triangle. What I just drew there is what just happened in that problem right there. Any questions? Alright, so this is like, if you wanted to think of this as the problem we just did, this side is your A, that's your A, same in each triangle. That's your B, that's your B, same in each triangle. This is side C1, this is side C2. They're different. This would be, let's see, this would be, what angle is, yeah, so this is your angle that's the same, and then you have an angle that's one size here, and then an angle that's a different size there. That's the two different angles. Then you have an angle that's a certain size there, and another angle that's a certain size there. Those are your two different angles. So two angles that are different, we found both. Another two angles that are different, we found both. And one side that was different, and we found both. So we found 6 things. Everything that's circled on the board. So that's the 2 solution case. Okay, let's look at this one. Okay, I'm not going to sketch it this time. How do I know that this is a law of science problem without making a sketch? It's got what?
A complete row.
Yeah, it's got a complete row. What else does it have that I don't really like?
Complete row.
Yeah, it's got a row that's totally empty. And you've got no way to find anything in that row, so we gotta check for the 1 solution, 2 solution, no solution. Okay, so this is side angle. Right. So I don't have any choice. What do I have to find first? We can't get B first because that's in a row that's totally empty. Yes, we got to do alpha first because it's in a partially empty row. We've got something to work with. We've got A, but we can't do B or beta because we're missing the whole row. So let's set it up to find alpha. So William, how am I going to set that up to find alpha?
Sine 50 over 1.
Yep.
And then sine over 2.
Sine of?
I don't know what that symbol's called. The one across from me.
Yep. Anyone remind him what's that symbol called? Alpha.
Alpha.
Sine alpha over
2.
2. Good. Let's cross multiply and see what we get. Really, because you have a 1 in the denominator, you don't even need to cross multiply. Really, you can just multiply each side by 2. 2 sine 50 equals sine alpha. Alright? And now, what do I do to get alpha by itself?
Inverse sine.
Yep, take the inverse sine. Now, before I do that, look at this part. 2 sine 50. When we studied sine and cosine last week, what was the highest and the lowest that sine went? Like if you didn't mess around with it, just normal. 1 and -1. Well, let's look at what 2 sine 50 is. If I type in 2 sine 50, I get 1.5. So imagine putting a line at 1.5. That's 1. We'll call that 2. Here's 1.5. Now I have a question. Where does that dotted line cross that graph? It doesn't. That dotted line never crosses that graph. If it did, that would be the answer. Okay, so when you do inverse sine, what you're really thinking of is where do two things cross on the graph? Well, on that graph they don't. So what do you think is going to happen when I type in inverse sine of 2 sine 50? Yeah, it's going to give me an error. Because you're trying to solve something that's impossible. That dotted line never crosses that graph, so you can't do it. So that means that there is no solution for alpha. What else does that mean? There's no solution for beta because normally at this point we would take what we got for alpha, we would check for a second answer. We can't even do that because you don't even have a number to subtract. So there's no way to find beta. Now if you can't find beta, you also can't find what's across from it, B. So the no solution case is the quickest one, and the only time that it can happen is with side-side angle.
So that's the answer, you can't do anything else.
Yeah, it's just no solution. And I'll show you why. I'm going to try to draw this. Obviously, if I actually try to draw this to scale, it's not going to work. I'm not going to be able to draw a triangle with an angle of, with a side of 2, a side of 1, and an angle of 50. That's impossible. Right, let me show you.
So if we immediately see that it's like side-side angle, we should automatically know everything's no solution?
Nope.
No, because you can have no solution, one answer, two answers.
Yeah. So we've done one of each case now. This last problem was side-side angle too.
Okay.
So this was a side-side angle that had 2 solutions. This was a side-side angle that had no solution. And then last night in the homework and in class, you did a side-side angle with 1 solution. So one of those 3 things could happen. So let me try to draw this. Okay. That angle right there, that's accurate. I did it with the protractor on the computer. That's a 50-degree angle, like exactly 50. So I need that, which I have. And then I need a side that's 2 units and a side that's 1 unit. Well, the easiest way to do that, let's call that 1 unit. If I want a side that's 2 units, just go like this. Put 2 of them together. All right? So there's a side that's 2 units. 2 what? 2 feet, 2 inches? I don't know, I don't care. It's 2 units. It's twice as long as the other one. All right. So A is the long side. So what I have to do is set A at a 50-degree angle. How do I do that? I'm going to use the protractor. Close enough. So I have A set at a 50-degree angle to the horizontal. Now B. All right. B we don't know. B wasn't given. C was 1. C is over here. It's the side that comes off the top. Now, notice when I click it, I don't have the little green handle on it, so I can't rotate it. But if I group it with something, and then I erased what I grouped it with, now I have the little green handle. Now I can rotate it any way I want. Okay, so I can put that right there. Now, side B can be any length you want. So let's put the bottom side. Make it as long or as short as you want. What you can't do though is you can't change B from being horizontal, because if you did, you would mess up that 50-degree angle. So you can make it longer or shorter, but you can't rotate it up because that would change the angle. So we can't change the length of A, we cannot change the length of C, and you cannot change that angle. The only thing you can do is make this longer or shorter. So we could go like that. And you can rotate this any way you want. This angle up here was not given. So if I keep rotating this side and making this longer and shorter, will the sides ever connect? No, that's impossible. To make them connect, you'd have to do one of 2 things. Either make this side longer, okay? You have to be allowed to make C longer, or you have to be allowed to make this angle something different. so you could rotate that other side up. Okay, but with the information they gave me, that's impossible. Can't do it. So that's the no solution. All right, so let's look at two word problems. Nice thing about word problems is usually if they're about a real life situation, there's always an answer. Okay? And there's always one. When you're dealing with a word problem, you're not going to have to worry about a two solution. Like if I said, what's the distance from here to the wall? There's one answer. It's not like, well, the distance could be 20 feet or it could be 300 feet. It could be either one. No, it's one or the other. So you only have to worry about a single solution. Okay. And the idea in this problem, what the person's going to do is they're going to measure the height of an object that's in front of them. It could be anything. It could be a building, a mountain, a tree. Doesn't matter, as long as you can see what you're trying to measure. And the idea is you stand in one spot, you look at the object, and then you back up, and you look at the object again. How much you back up is up to you. You could back up 30 feet, you could back up 2 miles. The point is you just have to look at the same object from 2 different points. Right? And this is all going to be done by one person. If you had a second person to help you, that would be easier. But if you don't, you just have to do it yourself. So the surveyor is going to stand in one spot, and they're going to measure the angle to the peak of the mountain. Now, how would you do that? You could use what's called a transit. If you've ever seen, like, anyone ever seen, like, on the side of the road, sometimes you see some people set up with, like, a tripod, and then there's, like, another tripod somewhere else.
I drove past someone doing that like 2 days ago.
Yeah, so what they're doing is they're measuring something. Maybe they're measuring the pitch of the road to see if there's good runoff. Maybe they're checking property lines. I don't know what they're measuring, but they're measuring something. So you could use one of those to measure the angle to the peak of the mountain. Now, this particular measurement, the way the person did it, is they did it 900 meters apart. So they planted all their gear in one spot, took a measurement, and then they backed up 900 meters, put their gear out, and did it again. How do they know 900 meters? Well, if you're in a car, you just use the odometer and just drive 900 feet or meters or whatever you want. So, in the first spot that the surveyor set up all their equipment, they used the transit, looked through maybe the sight on it, measured the angle of the top of the mountain, and it was 47 degrees. The angle of elevation is the angle from the horizon. So it's kind of like if you were trying to aim something at the mountain, right? Trying to hit a target on top of the mountain. It's the angle you would have to aim your projectile at to hit the target. All right. Now, think about what happens. If you're locked onto an object and you're real close to it, like I'm looking at the light, as I back away from the light, what happens to the angle between me and the light as I move further and further away?
Gets bigger.
The angle,
No,
so like,
smaller.
it gets smaller. Think of like how much I have to look. Like if I'm right under the light, I'm looking like almost straight up. As I start to move away from it, I'm not looking straight up anymore. I can look up less steep, kind of like if you're in a movie theater. You're right near the screen, you're looking straight up. The further back you are, the less of an angle you have to look up at. So when the surveyor backs up 900 meters, the angle goes down. This time it's an angle of 35. Now, technically you have to take into account the height of the transit, which might be like 5 feet or 6 feet on the tripod, but we're going to ignore that. That's not really a big deal. We're just going to assume the transit is level with the ground, which is not how they really do it. The transit's on the tripod. It's not on the ground. Okay. So what I want to find is the height of the mountain. Find the height of the mountain. Okay, so word problem. A lot of information there. What do you think we should try to do with all that information that was given to us?
Make a triangle.
Yeah, let's just make a sketch. The triangle is just going to happen if you put the right objects in your sketch. What's something that has to be in this picture? What do you need in your sketch? So for now, I'm just actually thinking physical objects. Don't worry about numbers yet. What physical objects are going to be in this picture?
Mountain.
A mountain. And what's the mountain sitting on? Maybe the mountain's floating, but I hope not.
Ground.
The ground. All right? So we've got the ground, and we've got a mountain right there.
Yikes.
Really steep on the back. In the front, it's a little risky on that part. All right, so we got our mountain. Now the surveyor is going to look at the height of that mountain from two different spots, here and here. What do I know about the distance between those two spots? It's 900 meters apart. So this is 900. Okay. And the surveyor is measuring the height to the peak of the mountain. So let's draw in almost like an invisible, like a laser from where they're standing right to the peak. Okay. So that's the first time. The surveyor sets up their equipment, aims it right at the peak. And then the second time, the surveyor sets up their equipment, aims it right at the peak. Now the first time they aim it at the peak, they get an angle of how much?
47.
Yeah, they get an angle of 47. That's right here. That's the angle that they had to tilt their equipment at to make sure it was aimed right at the peak. And then the second time, what do they get an angle of? 30, was it 35? Okay. So that's all the information they've given us. Now we want to find the height of the mountain. This is the height of the mountain. Let's try the line tool again. There we go. So that's, in fact, I'll make that make it a different color. So that red line, well, we can pretend it's red, or I can actually make it red. All right. So that red line is what I want to know, the height of the mountain. So what I'm going to do is I'm going to draw, or I'm going to trace, there's a couple triangles in this picture. Here's one of them. So I'm just going to trace it over. And I'm going to move it down below so I just have a little cleaner area to work with. Okay, let's label what I know in that triangle. 47 and the height. If I could solve for the height of this triangle, I would be done. There's other information here, so I'm probably going to have to use that somehow. But how come I don't have enough information to find the height in that triangle? You don't have any other sides. This is a right triangle, which means you can use Pythagorean theorem, you can use SOHCAHTOA, but you've got to have another side. Okay? You don't. Okay, so there's nothing I can do with that triangle yet. I'll come back to it. Here's another triangle. Right here. So we get this triangle. Now, these two triangles have something in common. What side do they share? Yeah, they share that side right there. So if you can find this side using this information, finding this side really means you just found that side. Right? So that's what makes it a little tricky. You can't find what you want right away. You got to find this side first, then you can find the height. Right? So let's label what we know about the triangle on the left. What can I label in this triangle?
35 degrees.
Yeah, this is 35. What else can I label?
900.
This is 900.
And you can, if you subtract 47 from 180, you can find an angle.
Yeah, very good. I know the other angle inside is 180 minus 47, so that's 133. Now that I know that, what else can I label? Because the key, if we're going to use law of sines, is you have to know an angle and a side across from it.
Add 35 and 133.
35 and 133, okay. So I get 168.
Subtract that from 180.
Okay, and what's that? That gives me 12. What's that?
That's the top angle.
It's the top angle. Now, by figuring out that top angle, you just made a complete row in your table. You have an angle and a side across from it. Okay? So let's set up the law of sines. Let's just call that side x, and let's solve for x. Okay. So, what's the angle that I know, that I also know the side across from it? 12. So we can do sine of 12 over, what's the side across from it? 900. There's your full row. You just used it. Sine of 12 over 900 equals sine of, what angle are you going to have to use to find x?
35.
Use what's across from it. 35 over x. Solve that, and then we'll have x. Now remember, x isn't the height of the mountain, but it's going to give me the number that I need to get the height. So, 900 times sine 35 divided by sine 12. Okay, let's see what we got. Let's get rid of that. All right, 900 sine 35 divided by sine 12. So we get 2,482 point, I'm just going to call it 0.9. I know we usually go to 3 decimal places, but that's okay. So this side is 2482.9, which means this side is 2482.9. Now you've got a side in the right triangle. So I want to find this, and I'm going to use that and that. You can use law of sines again, but it's easier to use Sokotoa. So let's find h. So what position is this side in? I mean, I know its name. Its name is h. But from the perspective of 47, it's the what side?
Opposite.
Opposite. And what position is the 2000 side in? It's across from the 90. Hypotenuse. Which trig function has opposite over hypotenuse? Sine. Yep. So our answer, our equation to get the answer is sine 47 equals opposite, which we don't know, over the number we just figured out. This is where we're going to use it. And now how would you get h by itself?
You multiply by 2.9.
Yep. So we're going to take the sine of 47 times 2,482.9. So that gives me a height of 1,815.9 meters, roughly. $1,815.9 meters. Okay, so what's a little tricky about that is you cannot find what you need right away. You got to find something else first. But that's the work for now. Okay, any question on that? Okay, so last problem we're going to look at, you don't have to find something else right away. You can get what you want. You don't have to find something else first. And this problem, it's going to be basically about a boat, okay, that's in the ocean, and 2 Coast Guard stations can see the boat. Okay, the boat, their radio's not working, GPS isn't working, it's nighttime, it's cloudy.
And then on fire.
They got problems, all right? So maybe they're on fire, or maybe they just have a really bright light on top of the boat, but they can see the boat. And the key is, if two people can see the same thing, they can figure out exactly where it is, as long as the two people are in different spots. They do that kind of thing with like fires. So like if it's in the middle of a forest, you usually have fire towers. Like there's one I'm talking about, Wachusett. There's other ones, other places. But if somebody is in that tower and they can see the fire, if they're the only one that can see it, that's a problem. Because all that the guy in the tower could say is, well, I got my compass and I can see the fire. Here's the heading, but I can't tell you if it's 10 miles, 20 miles, 30 miles. I just see something that way. Can't tell you how far that way. So that's a problem. But the key is if somebody else can see the same fire, maybe they're in another tower 30 miles away, and they say, yep, I see the same fire as you. So one tower can say, I see it this way. The other tower says, I see it this way. And it's basically like they see the same thing, and it's like they cross. And then they can tell you exactly where the fire is. And you could even have a third tower, but you only need two. All right? So that's kind of what's happening here. We've got two Coast Guard stations. And the Coast Guard stations are 120 miles apart. How would you know that? Well, that would be information you could look up on a map. The Coast Guard stations, it's like looking up the distance between, Fitchburg and Boston. You can look at a map. Right. And I just named the two Coast Guard stations Z and X, or Zulu X-ray. Okay, so ship sends out an SOS, and again, by SOS I mean there's a light. Maybe they just flash a light on top of the boat. Also, to make it a little simpler, we'll assume the boat's anchored. Because if the boat wasn't anchored, it would be moving the whole time, and that complicates it. So, the call or the light that the first station sees, we're thinking of more as a light, not really a radio call. But the first station says, okay, I can see the light, and the heading of it is 40 degrees east of north. That's the direction that they can see the light. How would they know that it's 40 degrees east of north? All they need is a compass. They just hold the compass, and they look, and it's 40 degrees east of north. Okay, the other station does the same thing. But since they're in a different spot, the signal's coming from a different direction. Okay? They see it 30 degrees west of north. Okay, so one station sees the light coming from that direction. Another station over here sees the light coming from a different direction. I want to know how far each Coast Guard station is from the boat. Okay, so the fancy word for what we're doing here is we're triangulating the position of the boat. Okay, and triangulation, it's used for all kinds of things in navigation. Okay, or like emergency rescue. You could do the same kind of thing, like if a cell phone tower can see your cell phone, meaning it can ping it. Well, if a cell phone tower pings your cell phone and another tower pings your cell phone, they can figure out where your cell phone is, which might be where you are, if you have your cell phone with you. And if there was an accident or something, they could roughly figure out where you are, as long as you could ping the cell phone. Now, if the cell phone's off, that doesn't work. Okay. So we're going to try to figure out, triangulate where the boat is. Okay, a lot of information. So, what do you always want to do when you have a word problem? Best thing to do is what? Cry. No. What else can you do? Okay, so the numbers are going to be important, but even more important than numbers, what do we got to do first? Yeah, we got to draw it. Put the physical objects in the picture. So, what we're going to have is the coast. Okay, you've got two Coast Guard stations. There's a boat. There's our boat. The waves? There's no waves. Isn't that weird? The ocean's perfectly flat too. So, there's no waves. But you can put waves if you want. Now, what do we know? Let's see. We got to put names on the Coast Guard stations. It says Coast Guard Station Z is to the west of X. So this is Z. This is X. Just make sure we know directions. This is north, south, east, west. So we got our Coast Guard stations. How far apart are they?
120 miles.
120 miles from here to here. Now, each Coast Guard station sees the boat. Okay, they see the light on the top. So the first one, I'm going to say they see it that way. The other one sees it that way. But they're both looking at the same light. Now, the directions that they give you, this is important. They're directions from north. North is up and down, okay, if you're going to draw it on the board. So what I need to do is put in a line that represents north, okay? like that. The arrow doesn't matter, just ignore that. Okay. That's north. Okay, and I'm going to put another line over here that represents north. North. Now, technically, you could say, well, shouldn't those lines for north be kind of like bent in a little bit? Because if you think about it, you hold the compass, everything points to the North Pole. Yeah, they should be bent in maybe just a little, but it's so little it doesn't even affect the problem. So don't worry about that. If the distance here was like 12,000 miles, yeah, they should be bent in a little, but that would make it harder. All right. So the first one, let's see, the call to station Zulu says that the radio signal or the light is coming from 40 degrees east of north. East is which way?
Right.
Right. So the signal is coming from right of north. How much? 40 degrees. 40 degrees to the right of north. Now the other one, I know it said west, but how much was it west? 30. 30 degrees west, or to the left of north. Okay? So now we've got our diagram. What I like to do is, I'm just going to trace the triangle out. I mean, you don't have to do this. You can do it right on the diagram if you want. But let's just move that triangle to a cleaner spot. Okay, so this side is 120. How much is that angle?
No, it's 50.
Well, this is a 90 right here. So that would be how much?
50.
50. Yep. And how much is this angle?
60.
60. Now, how much is the angle at the top? Because you've got to have an angle and a side across from each other.
70.
70. Because if you do 50 plus 60 plus 70, there's your 180. So now what I've done is I've taken out the word problem. If somebody were to just look at this diagram, like if they walked right in right now, they'd have no idea this is about a boat. It's just a triangle with a bunch of angles and numbers. So now we've gotten rid of the word problem part. Let's find A and B. And that's the distance to each Coast Guard station. So A, I forget which Coast Guard station was in the lower left, Zulu. So distance from boat to my boat, Zulu. And then we'll find B, which is distance from boat, my boat is getting worse and worse, to X-ray. Okay, so let's start with A. When I set up law of signs, what could I put on the left side? Yeah.
Sin 70 over 120.
Yep. Sine 70 over 120. There's your full row. Sine 70 over 120. Now you want to find A. What angle do you have to use to get A?
60.
60. Sine 60 over A. Okay, so let's type that in and see what we get. So 120 sine 60. 120 sine 60. And you're gonna have to divide by sine 70. Divided by sine 70. So the distance from the boat to the Zulu station is 110.6 miles. I think it was in miles. Yeah, it was miles. All right, now let's set it up for B. But the thing is here, you don't have to find like an extra side first. You can find the two sides you want right away. So sine. What can I put on the left-hand side again?
70 and 120.
Yep, same thing. Now, what angle are you going to use to find B?
50.
The one across from it. Sine 50 over B. Sine an angle divided by what's across from it. Okay, let's take that in. So 120 sine 50. I'm just going to retype it all in from scratch. Sine 70. So that Coast Guard station is a little closer. Roughly 97.8 miles. So now, each Coast Guard station knows exactly how far they are from the boat. They know the direction of the boat. They can pinpoint on a map. So if here's the map, one station goes like that, another station goes like that, and they know exactly where the boat is. Now that's assuming the boat's not moving. If there was like ocean current, it might push it somewhere. Also, just because you know the distances to the boat, it doesn't always mean that just because you're closer, you're going to send a rescue from the closer one. Maybe this one has a helicopter, and this one only has boats. Helicopter's going to get there quicker than a boat. So, but knowing the distance is all they really wanted to know in this problem. Okay. Any question on that? So it can be a little tricky to get the diagram part, but once you get that, you're good. Right? There's going to be a question on the test. I'm going to kind of give you a hint at what the diagram should be, because it's going to be about baseball. And if you're not familiar with what a baseball field looks like, it could be a little tricky, but I'll help you with the diagram.
I think you should put this exact number there.
This one? With the same numbers? Just change the numbers a little.
This one.
The baseball one's not really that hard. The baseball one is it's much easier than the first one. Okay, so homework, page 267, just 29 to 35 odd, and 39 and 43. Okay, so we'll go over that tomorrow. This finishes law of science, and tomorrow is our last lesson for the week.